Hello and welcome to The Chosen Few, the one and only place for you. My name is Isabel Santine, and today we're going to be checking out some progress on the Save project. So right here I have a videotape emulator. Now, more specifically, this is the physical tape simulation part of a larger VHS emulator that I haven't started quite working on yet, but this is the first key component that I've needed to build. So actually, let me go ahead and record this real quick on my phone. Right here, we have a regular old VHS cassette. And the cool thing is, this is my recorder in the background, the bigger version. If I hold this up to the screen, it's actually the same size as the tape. And if I hold two fingers up, this is about an inch, so it is correctly displayed as half an inch on the monitor. So usually when you have a magnetic tape, you basically have a few key components. You have the plastic part of it, which is the actual tape, and then you have it coated in a ferromagnetic substrate. And effectively what this means is that you can represent the surface of this tape as a 2D grid of different magnetic domains that represent little tiny particles in the tape substrate that basically have different magnetic alignments. So right now, all the tape that's coming in is being filtered through the erase head of the tape deck first, which means that all of these particles are currently aligned in the opposite direction, or in the direction of the tape's movement. But we can also choose to align particles in the direction opposite of the tape's movement, like so. So that's what the blue represents. And then the green and red represent, well, magnetic domains that are aligned with the direction of the tape's movement. All this is to say, we can basically have a tape head at an arbitrary position, positioned over a moving tape, and simulate how it would look to have that tape head write its own magnetic field onto the particles of the tape, which I think is really cool. So to give a more practical demonstration, usually in VHS, we have a bunch of diagonal lines on the top of the tape that represent the video signal. And usually these will be written by two heads simultaneously at a very astonishing rate. And then below these diagonal lines, we'll usually have a linear audio track and a linear control track. And basically what this simulation that I've developed allows me to do is move the tape underneath the tape heads at an arbitrary speed and have that tape actually be recorded as a digital file on the disc that is totally randomly accessible, so no need to read or scroll through manually the entire tape to get back to a certain spot. It's basically exactly like a nonlinear editing system, except implemented as a linear tape simulation, which I think is really cool. So then, if we close the simulation and then open it back up, so now we see everything that I recorded onto the tape during my demonstration, which honestly, I think it's super cool how all this works. Watch this. I can effectively put the tape head in one constant position, and as the tape moves under it, it gets recorded linearly, like it would in real life, which is actually harder to do than what you might think, given the programming constraints that I'm working within. Because not only does this simulation have to be real time, it also has to be semi-accurate to the real phenomena, and it has to be practical to use in terms of how much storage it's using on the disk. So yeah, that's pretty much all there is to this simulation for now. I'm hoping to continue to work on it and have a more concrete example complete with a reconstructed video signal very soon. So stay tuned for that. Thank you for watching. Bye!